Hello again, everybody. This is CJ, your local friendly technology addict, and you're watching the Tech Addict's Attic. Currently, my microphone is about 10 inches away from my mouth, and that is roughly 25 centimeters for those of you on the other side of the pond, or really anywhere else in the world, because the United States seems to be about the only place that uses the imperial measurement system. Anyway, I'm doing this video because I want to see if my amplifier is helping out any. I'm actually talking in a somewhat quieter than normal tone. If I were using my LG G5 to record this video by itself, I would be speaking up so that you could hear me very clearly, and when I do that on the LG G5, I've gotten reports from more than one or two people that basically say that my audio is very quiet. I just don't get that, because these phones are supposed to be able to record events that are happening 20, 30, 40 feet away, and there's no way that, as quiet as the audio is when I'm standing right in front of it, that it's going to be that quiet. So I'm not sure what's going on there. But here I am. I've made an amplifier, and I'm going to see if that'll work, see if it helps out any. And it's a fun project. It's something to kill the time, it's something to learn from, and it's actually been helping me toward the goal of getting my first homebrew HF rig built for ham radio, because I'm going to need an audio amplifier for an HF rig. And if I can make one that works well enough on this phone and has good enough quality for YouTube viewing, then maybe it'll be good enough for HF radio. So, here's what we have. I realize I probably should have moved all of this stuff over here, a bit closer to this stuff over here. However, all of this stuff is very finicky, and all of this stuff is very finicky, and I was simply trying to get everything as compact as possible. Maybe later on I will move all of this stuff if I need to continue building this thing, if I continue experimenting, etc. But for now, this will have to do. What we have is a three-stage transistor audio amplifier. Each of these transistors is a 2N5210 universal NPN. Not that you could actually see it. 5210. You gotta love that color balance, right? Now, the orientation of the transistors is emitter, base, collector, and pretty much they're all the same. I'll go over some differences in a moment. We have a capacitor leading to the input, which is the base, and you can see back here that orange wire is the base on all three of these. The yellow is the emitter on all three of these, and the green, aqua, and then whatever you want to call that color, teal, is the collector on all three. For the most part, what they have in common, all three stages, is a 100 nanofarad or 0.1 microfarad. As you can see here, it's marked 104 capacitor on the input to base as well as the output from collector. Between stages, the output from collector is the input to base through that capacitor. And then on the output we have a capacitor. Now, when I'm doing my tests and I'm using my function generator to inject a 160 millivolt sine wave, I place it on the input going through the capacitor. When I am using my electret microphone, I have to come directly to the base, because my electret microphone requires DC offset in order to power the FET that's inside the microphone casing. If I go through the capacitor blocks all DC, including my ground. So if I go through the capacitor with my electret microphone, I lose all audio from it. So really, For the purposes of my microphone, that capacitor is about worthless. All three stages are tied with a voltage divider from positive rail to negative. From base to positive is 100 kilo ohm on each one. From base to negative is 10 kilo ohm on each one. On each transistor, the collector has a 27 kilo ohm going to positive rail, and a 1 megohm resistor going between the base and collector on each one, with the exception of the third stage, which has a 1.5 megohm resistor. Where each is considerably different is the emitter to ground resistor. On the first stage, it is a 3.9 kilo ohm. On the second stage, it is a 2.2 kilo ohm. And on the third stage, it is a 1.0 kilo ohm. And this may cause a little static, but these are not touching, and I really don't want them to touch, even though it's not going to matter because they're tied into the ground anyway. But just for visual clarity, I want to show that they are separated. Now, what I have on this particular breadboard, you can see a bunch of jumper wires, and all of my jumpers are basically going from various test points of the circuit. So I've got the test point coming into the first capacitor, and then a test point going into the base, test point coming out of the collector, another test point going into the next stage base, the next stage collector, and then the third stage base and the third stage collector, and then of course the third stage collector coming out from that capacitor is my 8th test point. I'm not even going to bother using the first one. My microphone is currently on the second one because that is the base of the first stage, and I'm going to move my microphone through each of these to show you the amplification that we've got. Actually, I misspoke. I'm not going to use the microphone through each of those. I'm going to move my input wire through each of those. Of course, that wire is kind of short, so I'm going to move it, and I'm going to connect a new wire. So we should have audio again, and if it's a little staticky, I do apologize. I would like you to listen through the static. You're listening for my voice. Just tell me if I'm loud enough. Basically, loud and clear is what we're looking for. I'm going to loosen the tripod here, tighten it back up. There we go. And we're going to focus over there. And actually, you know what? I don't even have my oscilloscope plugged in right now. So I'm going to move that lead out of the way. Alright, so this is test point 8. It should be the same as what you were just hearing. Alright, so you can see that they are in fact. Same with this one here. I'm going to go to 7. Really and truly, there should be no difference, because we are going through a 100 nanofarad capacitor. There may be some slight tonation difference in my voice, but for the most part, you should be able to hear me just fine. This one here is test point 6. Now, this is the input to the third stage. As you can tell, it's very, very, very quiet. Same with this one, except this one's maybe a little bit louder. And that would probably be because of the loading of the third stage. Alright, we have test point 4. Now this one here is looks to me to be the base going to stage 2. This is test point 3, which is the collector coming out of stage 1. And finally, this is test point 1, 2, which is the base going into the first transistor. This is also the audio coming straight off of my microphone. So now what I'm going to do is go straight from coming right off of the microphone to going to test point 8, which is the full-on output from my amplifier, and we'll see what kind of difference we get. So this is straight out of the amplifier. So whatever you just heard a moment ago versus right now, what do you think? Is this good enough for YouTube? Can you guys hear me? Is my speech clear? Do you have any trouble understanding anything that I'm saying, or maybe do I need to still continue to speak up? Let me know. Let me know in the comments. I'm going to go ahead and make this video private first because I want to hear it for myself on YouTube using my own devices. However, if you're watching this, that means that, hey, it's good enough for my work, so I'm going to make it public and let you all tell me what you think. Please leave your comments down below, and I'll be looking forward to them. Until next time, once again, this is CJ, and you've been watching the Tech Addict's Attic. See you next time.